Alright, in this video we're going to be creating a program that allows us to turn our robot to a certain degree, a certain angle. So, we're going to be using something called a proportional control algorithm. We're going to be using proportional control, and what that means is basically we have a certain variable called error, and over time that value changes. So over time our error is going to be decreasing, and as it decreases, we're going to use that error and calculate the speed or the power that we want our robot to be moving at. So that's what we're going to be doing, or that's what we're going to be doing in this program. Yeah, let's get started. So the first thing we need to do is go to Spec Prime, click New Project, and we want to be using the word blocks, and you can name it something. I'll just keep it as Project 1. Alright, so we're going to be turning this also to a my block eventually, but let's first go ahead and build the program. So the first thing we need to do is, if you haven't already, we need to add a couple more new blocks into Spike Prime Classroom. So go down here to the bottom left and click on Show Block Extensions, and then you want to click, we only really need one right now, more movement, but some of the other ones are helpful as well, like more motors and more sensors and line graph. Those are also helpful as well, so you can also click those. But we definitely need this more movement because we're going to be using the blocks from the more movement tab. Alright, once you have those, you should see it immediately. If you scroll all the way down, you should see more movement, and if you have the other ones, you should also see them as well, but we need the more movement one. So make sure you have that. Alright, so after we've done that, we need to go ahead and make our variables. So we're going to be creating a couple of variables. 6. We're going to create one called controller output. We want to create one called error. Another one called maximum power. Another one called minimum power. Another one called P constant, our proportional constant. Another one called target value, and this is our last one. So yep, there we go. So those are our 6 variables: control output, error, maximum power, minimum power, P constant, target value. Alright, so once you have those, we only really need to be monitoring about like 2 of them. We need to just look at the error and the controller output. We don't need to see the other ones. Alright, so what we need to do first, we need to go ahead and set our variables in the very beginning of our program, and also set stuff for our robot, guidelines that our robot needs to follow. So the first thing is we need to set our movement motors. We're going to set those to B and C. And usually in like FLL we use B and C, but if you do want to set it to something else, that is fine. Just make sure that you are plugging them in correctly. So your left motor should be the one that comes here first. So if I was using D and A, D should be my left motor because that comes first, and then A should be my right motor. But I'm going to be using B and C. So here B is going to be my left motor, C is going to be my right motor. Alright, next thing we need to do is, I'm going to go ahead and put this first actually. I'm going to set my yaw to 0. So yaw is going to be the gyro, the inbuilt gyro. That's the angle that's going to be measuring. But little side note, gyros don't actually measure angle. They measure something called angular velocity. But using angular velocity, they can calculate an angle. But I'm going to set that to 0 at the beginning. After that, I'm going to set my movement motors to hold position when it stops. So I'm going to go down to more movement motors, and more movement, the more movement tab with more movement blocks, and I'm going to set my movement motors to hold position at stop, which means they're going to brake, and they're also not going to move at all. Even if they were pushed, they're going to snap back into position. And you can use brake as well. The one you don't want to use is coast, because it'll keep on moving once your program is done, which is not good because you want your robot to stop at that given angle, right? You don't want it to keep on turning. Alright, the next thing we need to do is go ahead, and if you want, you can set your acceleration. So I'm gonna set mine to be I haven't seen any noticeable changes with this, but I'm just gonna go ahead and set it to maybe smooth. You can play around and see what works best for you, but I haven't found that there's anything major, there's a major difference between any of them. The next thing we need to do is set some of our variables. So we're going to be setting 5 out of our 6 variables. One of the variables we're going to set that inside our loop. So the first variable we need to set is going to be our target value. And for the sake of this example, I'm going to use 90. So that means we want to turn 90 degrees. That's our target value. The next variable we're going to set is our P constant, and that's going to determine how sharp our robot turns. So a higher P constant would mean our robot spins and turns, accelerates faster, and a smaller P constant means our robot accelerates slower when it's turning. So we always want to be kind of in the middle, not too fast, not too slow. And that value is going to be anywhere from like 0.6 to 0.8 or so. And this can also depend on how heavy your robot is. That has a major influence on it. So if you have a bigger robot, you might want to use a bigger P constant. But I'm going to use 0.6. The next thing that we need to do is set our initial error. We're also going to be setting our error in the loop. So in a proportional control algorithm, the error is always going to be equal to your target value minus your current value, the value that you're at. And this is going to, of course, change over time. But I'm going to set the error to exactly that. I'm going to set it to target value, which here is 90, minus my current value. And in this case, it's going to be the current angle of our yaw. And when it begins, the error is going to be equal to 0, right? Because our target value is 90, and our yaw angle, we set it to 0, so it's going to be 0. 90 minus 0 is 90. So that's our current error when we start. And our goal is to get our error to be 0, because when our error equals 0, that means we are at our target value. So next, I'm going to add my 2 other variables, minimum and maximum power. And so we are going to be constraining our robot to have a minimum power of 12, about 12, or I'm going to use 14, and a maximum power of 100, of course, because 100 is the highest we can go. It should be minimum and then maximum. There we go. So those are our 2 constraints. And then the next thing that we need to do is make a repeat until block. We're going to go to control, repeat until, and this is going to be our main loop that actually does most of the program. This is where most of the work is being done. So in this repeat until, we want to set a condition. We want to repeat until our error is equal to 0. Because remember, when our error is 0, then our robot is at its target value. So repeat until error is 0. Then the next thing that we need to do is set our error, because we need to change it in the loop, or else it'll just keep on going and never reach 0 because we haven't changed it. So we're going to set that error to be the same thing that we set it here. So we can just copy this. It's going to be equal to our target minus our current value. So target value 90 minus our current value, whatever the yaw angle is reading. And just as another side note, the max you can turn here is going to be 179. You can't do 180, and that's because the yaw angle only measures up to 180. And if you try 180, it's a little bit finicky, so it won't work. 179 is the max you can go, about 179. So don't try to turn it more than 179. And then, of course, the minimum, you can do negative angles with this program, but it'll be the same thing, just negative. So negative 179 is going to be the minimum. But here we're going to be trying 90. The next thing that we need to do after we've set our error inside our loop is to set our controller output. And so the controller output is basically just going to be our error times our P constant, and that's going to just kind of, it's going to act as a multiplier to our error, which is going to be, the controller output is going to be what we're actually plugging in to our motor's speed. So we're not actually plugging in the error, we're going to be plugging in the controller output after we multiply it to something else to either increase that error or decrease that error. We're going to kind of make the error bigger or smaller with our controller output. In this case, since our P constant is lower than 1, it's going to make our error smaller. It's going to multiply it to make it smaller. So the controller output is always going to be smaller than our error. So to do that, we're going to go to operators, multiply, and we're going to take our variable error and multiply it by our p constant. All right. So after that, we need to make a couple of constraints. So remember, we made these variables called minimum power and maximum power. So we need to actually tell our program that if we see a value for this controller output that is smaller than the minimum power or greater than the maximum power, we need it to go back to that minimum. We don't want it to go below this. It can be this, but it cannot be below this. So if we have 13, that's not good. If we have 105, that is not good because that's out of our range. So how to do that, we're going to go to controller, we're going to get an if, and in our if, we're going to say if, and we're going to get a greater than, if controller output, and we actually need an absolute value bar for this, and that's just so that we can do negative angles. If our absolute value of our controller output is greater than our maximum power, then we need to set it again. We need to change it. We need to set it back to our maximum power. So we're going to set that controller output to our maximum power. Now we actually have to add a little bit more here because we might be using negative angles or we might be turning to a negative degree. So what we're going to do is we're going to set it to our maximum power, but we're going to set it to our maximum power times. So I'm going to get a operator, a multiplier, right? A multiplication block here, maximum power times, and I'm going to now get a division block, going to be maximum power times target value divided by the absolute value of target value. And make sure you do this or else the program won't work with negative degrees. So make sure you do target value divided by absolute value of target value. Alright, next we need to I'm just going to copy this because it's going to be sort of the same, and now we're going to do it for minimum. So now we're going to change absolute value controller value. We're going to keep that. We're going to take out this block and bring in a less than sign. Well, we're going to bring out a less than and then just switch the values. And now make sure you change this variable to be minimum power. So that should be if absolute value of controller output is less than minimum power, then we're going to set that controller output to our minimum power times, and we'll keep the rest the same. Target value divided by absolute value of target value. There we go. Alright, the next thing that we need to do is we're going to actually start moving the robot because right now we haven't done anything. We're going to go to more movement, and we're going to drag out a start moving at 50-50 power block, and we're going to put variables in for both of these. So the first one is going to be we're going to go to variables. First one's going to be just controller output. The second one is going to be controller output, but we're going to multiply it by -1, so it goes in the opposite direction. That way the robot is able to turn, but it's going to be turning on its axis, so it's not going to be making like a swing turn. It's going to be moving both of its motors to turn. One is going to be going forward, one is going to be going backwards, therefore the robot will be able to turn. So -1 times controller output. And then the last thing that we need to do is actually stop moving our motors, and this is going to go outside of the loop. Make sure it's outside of the loop, or else it's never going to move. So we're going to go to we just need to go to our regular movement blocks and then take a stop moving. Make sure you put it outside the loop. And also make note of in this start moving at block, make sure you make the first one just controller output and the next one negative controller output. And this is important because if you're using this B plus C and you're making the left one this motor and the right one this motor, then this is going to work. But if you change it up, it's not going to work. So make sure whatever motors you're using, the left one is going to be B, or your left motor is going to be the one that comes first, and your right motor is going to be the one that comes second. And also make sure you have controller, then negative times controller output. So this is important for your power. Alright, and this is pretty much it. So I'm going to go ahead and test this on my robot and make sure it works. And then we're going to turn this into a my block. And you can't actually see the robot, but I will show it at the end of this video, but you can monitor the values. So the error should start off at 90 and then slowly get to about 0. and we're turning 90 degrees. There we go. So our error is 0, and we are able to turn, let's see if we can turn a negative degree, so negative 90. There we go. Alright, so it works perfectly. The next thing that we need to do is turn this into a my block, because if we want it to turn 5 times, we're not going to bring out this entire program 5 different times. We want to just make a function that we could call out in different parts of our program. So to do that, we're going to go down to my block. We're going to click make a my block, and I'm going to name this one turn robot. And we're going to have just one input, so we're going to add an input here on the left, and this input is going to be called angle. That's the angle that we're going to turn our robot. And then I'm going to add a label, and just so I know what we're measuring in, I'm going to type in degrees. And so I'm going to save that, and now it's going to bring out this, and I'm going to disconnect my entire program from the when program starts and put it under my turn robot my block, and then I'm going to take out this angle variable, and our angle variable, whatever we type it in, that's going to be equal to our target value, or rather our target value is going to be equal to whatever angle that we type it in. And maybe for simplicity we can edit this, and instead of angle we could just say target value, so we know it's the same thing. There we go. So we're setting our target value to whatever we type it in, and yeah, there we go. So now we can use this my block, we can call it out, and we can turn our robot to whatever we type in. So if we want it to turn 90 degrees, now when we play it, the robot will turn 90 degrees. There we go. So this is pretty much it. Again, you can use negative angles, you can turn the opposite direction, and yeah, that's pretty much how you use a P controller to turn your robot with the spike prime. And the same can be done with the EV3 even. It'll look really similar to this. You just will have to use the gyro sensor, since that one is not built in, but it works the exact same. So yeah, that's how you go ahead and build this. And again, you can experiment with these P constants to see what values work for your specific robot, because 0.6 won't work for everything. Again, if your robot is not able to turn all the way and it's still kind of humming, the motor's is still kind of humming, you need a higher P constant. But if you have too high of a P constant, you'll notice that your robot doesn't turn exactly how much you say it should. So if you set it to 90, it might turn more than 90. So if that's the case, then you want to reduce this P constant. But make sure you edit these P constant. The only other thing that you might need to edit is this minimum power. If you have a bigger, heavier robot, this might need to increase. You might have a minimum power of like 18 or like 20, and you can also change that. And it's the same thing applies. So if your robot is turning and then stopping and not going the full 90, you might need to increase that minimum power. And if it's turning too much and kind of shifting back and forth, you might need to decrease it, so that it's able to kind of slowly come to a stop and not continue moving after it's gotten to a zero error point. Alright, and that's how you make a P controller to turn your robot. Alright, so the first thing I'm going to show is the robot turning 90 degrees. So I have the program pulled up, the same one we just made, and I'm going to type in 90 here, and I'm going to play it. So it moves pretty swiftly, pretty smooth, and turns to that 90-degree position. And you can see that as it's turning, it's slowing down over time, which is that P controller. And you also notice that it's holding its position. That's what that block does in the program. And yeah, so the next thing we're going to show is it moving that same amount, but I'm going to type in a higher P constant. So remember we had that variable called P constant. Instead of 0.6, I'm going to make it maybe like a 2, and I'll show you why you don't want it to be this high, because 2 in this program is really high. So I'm going to play this, and it's going to turn 90 as well, but watch what happens. You can see it's not exactly getting to 90. It went past 90, and now it's just fluctuating. It's not getting at a resting point, so the program is still running. It's not stopping. And if I hold it maybe and try to turn it swiftly, it might stop. But that's why you don't want too of a high of a number, because it won't get to a resting point. It's still thinking it needs to have a lot of power to turn it, which in reality it doesn't. So that's why we need it to be smaller. And as you can see, If we reduce it to like 0.6, it should be able to turn a little swiftly. There we go. And now it's rested. So if you have that problem, your value is too high. The next thing I want to show is what happens when your value is too low. So let's try 0.2. 0.2 will probably be too low, and it might not go all the way. Or it might still go all the way, but it might not do it fast enough. So let me try 0.2. So this works. Again, it went all the way, but if your aim is to go fast and complete missions fast, you might not want it to go this slow. But you can if you want it to. Now I'm going to show what happens if the minimum power is too low. If I set that to like 5 instead of 14, now it won't go all the way. So it'll stop at a certain point before it reaches 90 degrees. So and as you can see, it's stopped in the middle. It's gone about probably like 45. It hasn't reached the full 90. And that's because this minimum power is too low. So if that happens, change it to something higher. So 14, I found that 14 works good. But if you have a bigger robot, because this one isn't really much of a robot yet, it's just like a driving base. If you have a bigger robot that's like fully built and has a lot of weight to it, you might want that to be higher, but you're gonna have to test it out. And yeah, don't change the maximum power, because that maximum power will never change. It'll always be 100 power, 100%. All right, and yeah, that's it. The last thing I'll show is it turning a negative degree. So we were turning right. Now I'll show you to turn left, how to turn left. And for that, we just type in a negative value, like negative 90. Oh, I forgot to change my P constant. I should be about 0.6, but you got the idea. It can do more than 90. It's not just restricted to moving 90 degrees. So like you could do negative, let's do more than 90. Let's do negative 130 degrees or 135. There we go. And it's turned exactly 135 degrees. All right, and that's how you make it.